Okay, I want to make another video about really niche audio stuff that no one cares about. I saw a video on YouTube of some guy comparing the output waveforms of a couple different synths and looking at the sub oscillator on one of the synths and being like, this looks funny. And it looked funny. It was meant to be a square wave. It didn't look like a square wave. But I think a large part of that might be due to the fact that a lot of the general use audio hardware that we use at home, like audio interface, is AC coupled. The input is AC coupled, and that basically just means that there's some capacitor in line with the input to act as a filter to filter out DC signals. And there's probably some non-trivial phase shift associated with that at low frequencies. And I guess non-trivial probably mostly means that you can see it. If you're looking at an oscilloscope, it probably doesn't matter too much in terms of well, I guess I don't want to say much about how it might sound or not, but you can definitely see the effect that that phase shift will have in the passband. Even if you're in the passband where the magnitude isn't really affected, you can definitely look at the waveform and see the phase shift, especially when you're looking at a more complex waveform. So, for example here, I have my sound card playing this pretty nice looking square wave, and it reads in this kind of like square-ish, saw-ish thing, and here's my audio interface that just I'm playing out and back into it. So this is what you get with the AC coupling of the audio interface. Now, doing my due diligence, I should point out that it's not necessarily certain that my hypothesis is correct, because this distortion could be due to the fact that the interface isn't capable of playing the square wave correctly. So the distortion could be appearing at the output and not at the input. So to confirm, I have some really high-powered data acquisition hardware at home with me right now, and that'll give me a much better answer using something that costs like as much as my car, this audio hardware. So this is the measurement when the input on the National Instruments hardware is also AC coupled. So it's a similar shape. Again, I'm hypothesizing there's some inline filter here to filter out DC. It's certainly not the same exact filter in both cases. This is the filter that's on my audio interface. This is the filter that's on this National Instruments hardware, but you get a similar shape when you AC couple the input. What essentially none of these home audio interfaces can do is record DC coupled signals, and that's basically just without that inline filter on the input, but I can select a DC coupled input on my more high-end hardware, and when I do that, I get this pretty perfect recreation of my output signal. So that's essentially confirmation that the DAC is generating the right waveform, and it's the input where this distortion occurs. And you can play around with a filter and just kind of see that even in the passband, some amount of residual phase will affect the shape of a waveform. So the frequency I've been using is 50 or 40 hertz, which seems poignant. That's the fundamental of a bass guitar. Makes sense to use that frequency. That's probably the range a sub-oscillator on a synth would be. So here I have a digital filter. It's turned off at the moment, but even with a cutoff frequency of 1 hertz, I'll activate it and you can see the effect it'll have on this shape here. So that's a huge effect, that even though the cutoff frequency of the filter is 1 hertz and the wave I'm playing is at 40 hertz, we get this huge change in the waveform. And if you looked at the energy at the fundamental, it likely wouldn't be that much of a change. It's hard to tell because the shape is so drastically changed, but I'm hypothesizing here that it's really the shape that's primarily changing, and that there's just a phase shift that's creating this kind of more extreme triangular shape here when I toggle this 1 hertz filter on and off. And I think that's essentially akin to the input coupling on these devices. Yeah, so that's all. If you're watching a video on YouTube and someone says, this sub-oscillator waveform looks weird, send them to me and I'll set them straight.